In the 21st century, the focus has been more on steps towards sustainable presence on the Moon. NASA launched the Lunar Reconnaissance Orbiter in 2009, which produced the highest resolution Moon maps, including images, topography, temperatures, etc. Its extensive dataset has helped plan nearly all modern-day Moon landing missions and will help future ones like those part of NASA's Artemis human landing program. The Artemis program envisions landing humans on the Moon's south pole, where the water ice is. Data from ISRO's Chandrayaan-1 orbiter shows the water ice is in the frigid, permanently dark craters on the Moon's poles. As the next logical step, Chandrayaan-2's orbiter, launched in 2019, is quantifying the amount of water ice on the lunar poles and mapping it. How much water does the Moon have? Based on remote observations by radars onboard ISRO's Chandrayaan-1 orbiter and NASA's Lunar Reconnaissance Orbiter, scientists estimate the Moon's poles to host more than 600 billion kilograms of water ice, enough to fill at least 240,000 Olympic-sized swimming pools. The lunar science and exploration communities agree that we can harness water ice on the Moon's poles to power future habitats. But before we plan lunar habitats, we need technologies that enable us to explore the Moon's poles. This includes an ability to land on and navigate rough, mountainous terrain on the lunar poles, and function in the frigid water-hosting regions without access to sunlight or Earth communication. This is where NASA's next lunar mission, Viper, comes in. Slated for launch in 2023, NASA's Viper will explore permanently dark craters on the Moon's poles to make high-resolution maps of water ice and probe it.
Where did the Moon come from?
The origin of the Moon is a fundamental question in planetary science. The Apollo human missions and the Soviet Luna robotic missions combined brought about 383 kilograms rock and soil samples from the Moon. These samples are analyzed even today in laboratories around the world and continue to provide insights on how the Moon formed. In fact, scientists think the Earth and the Moon may have a shared origin. While the Apollo and Luna samples revolutionized our understanding of the Moon's origins, they were from largely similar geological areas and thus not representative of the entire Moon. The jury is still out on how the Earth-Moon system formed and what were the conditions in the early solar system. To unlock these fundamental mysteries, more samples from across the Moon are required, including access to more pristine rocks below the lunar surface and water from the lunar poles. That is where NASA's Artemis program to land astronauts on the Moon's south pole is most intriguing. Like the Apollo program, Artemis is expected to offer abundant scientific opportunities, including lunar sample return.